Imagine looking up at the night sky and seeing not one, but two moons hanging above you. One larger, one smaller, dancing around each other in an eternal cosmic ballet. Beautiful, right? Well, hold that thought, because what I'm about to tell you will completely shatter that romantic notion. If Earth actually had two moons, you wouldn't be here to admire them. In fact, human civilization as we know it would be utterly impossible. The catastrophic forces unleashed by a second moon would turn our planet into a chaotic, uninhabitable nightmare. But here's the really mind-blowing part, and this is what kept me awake for nights after researching this. Even if we could somehow survive the initial chaos, the long-term consequences would be so bizarre, so alien, that Earth would become completely unrecognizable. So buckle up, because we're about to explore one of the most fascinating what-if scenarios in astronomy, and I guarantee that by the end of this video, you'll never look at our single moon the same way again. Let's start with the most immediate and devastating consequence: tides. Our current moon already creates tides that rise and fall about 12 feet on average. But with two moons, we're talking about a completely different game. The gravitational forces from two moons wouldn't simply add up. They would interact in complex, chaotic ways. When both moons align on the same side of Earth, their combined gravitational pull would create what scientists call super tides that could reach heights of 100 to 200 feet. Imagine walls of water taller than skyscrapers crashing onto coastlines twice a day. But here's where it gets really terrifying. When the two moons are on opposite sides of Earth, they would pull the oceans in different directions simultaneously. This creates something called tidal interference patterns. The result? Completely unpredictable tidal behavior. One day, a coastal city might experience a gentle 10-foot tide. The next day, a 150-foot tsunami-like wall of water could obliterate everything for miles inland. Now picture this: New York City underwater for half the day, then completely dry and exposed seafloor where the harbor used to be just 12 hours later. The Statue of Liberty would spend part of each day submerged up to her crown, and the rest of the day standing in a desert of dead fish and seaweed. This isn't science fiction. This is the mathematical reality of dual moon tidal forces. These megatides wouldn't just destroy coastal cities. They would fundamentally alter Earth's geography. Continental shelves would be constantly reshaped. Entire inland seas would form and disappear within days. The Great Lakes could drain completely during extreme low tides, only to overflow their banks catastrophically when the tidal forces reverse. Rivers would flow backward for hundreds of miles, creating temporary inland deltas that would vanish as quickly as they appeared. The constant bombardment of extreme tides would create a planet where the distinction between land and sea becomes meaningless. Coastal mountain ranges would be carved into bizarre formations by the relentless water, while inland valleys would be flooded and drained so frequently that no permanent ecosystems could establish themselves. Now let's talk about the orbital mechanics. Having two moons orbiting Earth creates what astronomers call a three-body problem, one of the most complex puzzles in physics. Unlike the stable, predictable orbit of our single moon, two moons would constantly influence each other's paths. Initially, they might settle into what's called a resonant orbit, perhaps one moon completing two orbits for every three of the other. But here's the crucial point. This system would be inherently unstable. Over thousands or millions of years, the gravitational interactions between the two moons would cause their orbits to slowly decay. The physics behind this instability is fascinating and terrifying. Each time the moons pass close to each other, they exchange orbital energy through gravitational interactions. The smaller moon would gradually lose energy and spiral inward, while the larger moon would gain energy and move outward. It's like a cosmic game of gravitational ping pong, but with catastrophic consequences for everything on Earth's surface. During these orbital decay periods, Earth would experience what scientists call tidal resonance cascades. As the moons drift closer together, their combined gravitational effects would create rhythmic pulses of extreme tidal activity. Imagine weeks where every high tide is a 300-foot wall of water, followed by periods where the tides become so chaotic that coastal regions would be impossible to inhabit. The smaller moon would likely be the first casualty. As its orbit deteriorates, it would either crash into Earth or be flung out into space. If it crashes, We're looking at an extinction-level impact that would make the asteroid that killed the dinosaurs look like a firecracker. The impact would release energy equivalent to billions of nuclear weapons, vaporizing oceans and turning the atmosphere into a hellish inferno. If it gets ejected, the sudden change in gravitational forces would cause massive earthquakes and volcanic eruptions across the planet. The Earth's crust, which had adapted to the stress patterns of two moons over millions of years, would suddenly be subjected to completely different forces. Every fault line on the planet would activate simultaneously. But even before this ultimate catastrophe, the changing orbital dynamics would create periods of extreme instability. There would be times when the moon's combined gravity pulls Earth's axis in different directions, causing dramatic climate shifts that could happen over just a few decades instead of millennia. Ice caps would melt and refreeze in cycles measured in years rather than millennia. A world without seasons, as we know them. Speaking of climate, let's examine how two moons would completely revolutionize Earth's weather patterns. Our single moon helps stabilize Earth's axial tilt at about 23.5 degrees, which gives us our predictable seasons. With two moons pulling in different directions, Earth's axis would wobble chaotically. This means that instead of gradual seasonal changes, we might experience rapid shifts between ice ages and extreme heat waves. The Arctic could become tropical within a human lifetime, while temperate regions could freeze solid. Agriculture would be impossible because there would be no predictable growing seasons. The atmospheric effects would be equally dramatic. The extreme tidal forces wouldn't just affect oceans, they would also create massive atmospheric tides. Wind patterns would become completely chaotic, with hurricane-force winds appearing suddenly in typically calm regions. The jet streams would shift unpredictably, creating weather systems unlike anything we've ever experienced. Imagine trying to predict the weather when the very forces that drive atmospheric circulation are constantly changing. Modern meteorology would be useless. We'd live in a world of perpetual weather chaos. Now, let's consider the biological implications. Could life have evolved on a two-moon Earth? The answer is both fascinating and terrifying. In the shallow seas that would constantly shift between land and ocean, we might see the evolution of incredibly adaptable organisms. Creatures that could survive both underwater and on dry land for extended periods. Think of extremophile organisms, but taken to an entirely new level. These hypothetical organisms would need to develop biological mechanisms we can barely imagine. Picture creatures with dual respiratory systems. Gills that could rapidly seal, shut, and transform into primitive lungs within hours. Their cellular structure would need to handle massive pressure changes as they're alternately crushed by hundreds of feet of water, and then exposed to atmospheric pressure. Plant life would need to develop rapid adaptation mechanisms far beyond anything we see on Earth today. Instead of seasonal cycles, plants would need to respond to completely random environmental changes. We might see species that could rapidly alter their metabolism, going dormant during chaotic periods and explosively growing during brief stable windows. Consider the evolutionary pressure this would create. Any organism that couldn't adapt within a single generation would go extinct. This would lead to incredibly rapid evolutionary cycles. Species might evolve and adapt to new conditions within decades rather than millennia. The genetic diversity would be staggering, as only the most flexible and adaptable traits would survive. Marine ecosystems would be unlike anything we can imagine. Deep-sea creatures would need to survive being suddenly thrust into shallow, sunlit waters during extreme low tides. Coral reefs would be impossible. Instead, we might see mobile, semi-terrestrial ecosystem structures that could migrate with the constantly changing waterline. But here's the really intriguing part. Intelligence might never have evolved. The constant environmental chaos would favor simple, highly adaptable organisms over complex ones. The evolutionary pressure would be on survival flexibility, not on developing advanced brains that require stable environments to flourish. Complex neural networks need consistent conditions to develop the sophisticated connections that lead to higher consciousness. If intelligent life did somehow emerge, their society would be fundamentally different from ours. They would be nomadic by necessity, never building permanent settlements. Their entire culture would revolve around reading the subtle changes in their moon's positions, to predict the next environmental catastrophe. They would be master astronomers by survival necessity, developing mathematical models that make our current astronomy look primitive. Their architecture would be revolutionary, buildings that could be rapidly assembled and disassembled, structures that could float during high tides and anchor themselves during low tides. They might develop a form of architecture that's part building, part boat, part underground bunker. The night sky spectacle. Despite all the chaos and destruction, we have to admit that the night sky would be absolutely breathtaking. Imagine watching two moons of different sizes moving across the heavens at different speeds. Sometimes they would eclipse each other, creating spectacular light shows. Other times, they would appear to chase each other across the sky. The smaller moon would likely appear to move much faster, completing its orbit in perhaps 10 to 15 days, while the larger moon might take 35 to 40 days. This would create ever-changing patterns of moonlight. Some nights would be incredibly bright with both moons full, while others would be pitch black when both moons are new. Solar eclipses would become incredibly complex events. Instead of the simple, predictable eclipses we experience, we'd have partial eclipses, double eclipses, and completely unique eclipse patterns depending on the alignment of both moons with the sun. The cultural impact on any surviving civilization would be enormous. Their entire mythology, calendar system, and timekeeping would revolve around the complex dance of two moons. They might worship the moons as gods of chaos and change, developing philosophies centered around adaptation and impermanence. The mathematics of madness. Let's dive into some specific numbers to really understand the scale we're dealing with. If we had a second moon about half the size of our current moon, orbiting at roughly the same distance, the combined tidal forces would be about 2.25 times stronger than what we experience now. But the real chaos comes from the interference patterns. When the moons are aligned, tidal forces could reach up to 3 times normal strength. When they're perpendicular to each other, we'd experience bizarre tidal patterns where different parts of the ocean would be pulled in different directions simultaneously. Here's where the physics gets truly mind-bending. The tidal bulges created by each moon would travel around Earth at different speeds, creating what physicists call standing wave interference. This means that in some locations, the tidal effects would completely cancel each other out, creating perpetually calm seas. But just a few hundred miles away, the tidal forces would amplify each other, creating permanent whirlpools and tidal bores that could be seen from space. The mathematical models show that these interference patterns would create tidal dead zones, areas of ocean that experience almost no tidal movement, and tidal superstorms, regions where the water level could change by 400 feet within 6 hours. The energy released by these tidal movements would be equivalent to thousands of hurricanes occurring simultaneously across the globe. The gravitational stress on Earth's crust would be immense. Our planet would experience constant seismic activity as the changing gravitational fields literally stretch and compress the solid rock. The Earth's surface would rise and fall by several feet twice a day, not just the oceans. Fault lines would be under constant stress, making devastating earthquakes a weekly occurrence rather than rare events. Computer models suggest that Earth's rotation would also be affected. The complex gravitational interactions would create a rotational wobble that would change the length of days and nights unpredictably. Some days might be 20 hours long, others might stretch to 28 hours, and the pattern would be completely chaotic. Even Earth's magnetic field might be affected. The core's rotation could be influenced by the complex gravitational interactions, potentially weakening our magnetic shield against cosmic radiation. This would make the surface even more hostile to complex life, as deadly radiation from space would penetrate deeper into the atmosphere. Perhaps the most sobering aspect of this scenario is that it would be temporary on cosmic timescales. The chaotic orbital mechanics would eventually resolve themselves through catastrophe. Computer simulations suggest that a two-moon system around Earth would likely collapse within 10 million years, a blink of an eye in astronomical terms. The end could come in several ways. The moons might collide with each other, creating a spectacular fireworks show that would briefly give Earth a ring system before the debris either falls to the surface or gets ejected into space. Alternatively, one moon might spiral into Earth while the other gets flung out toward Mars or beyond. In either case, the survivors would witness one of the most spectacular and terrifying events in the solar system: the violent end of their double moon world.